All right, so this is our semi-fast and furious units 3C through 3F for AP Classroom that we're going over. So it's showing your checkpoint 3.2, and then the last that you need to know for the finals, okay? So you should have picked up the paper out of the basket, and we're going to begin. So let me hide this. So to begin with, it's a review of what we've already learned about polynomials. So for the previous couple of weeks, we've talked about polynomial functions and their end behaviors, leading coefficient, their degree, the number of terms. Are those words ringing a bell? Yeah, remember those? Okay. So right here, I got tired of trying to use math font. So this is actually negative 2x to the 4 plus 3x to the third minus 5x plus 1. And like we've been studying thus far, how do you determine the degree of this polynomial? Anybody, everybody? The highest exponent. What is my highest exponent? So the answer is simply 4. It's a fourth degree polynomial. Agree? Remember that? Okay, good. Next it says, what is the leading term? So if I have g of x equals 4x to the fifth minus 2x to the third plus x. It's specifically asking for the leading term. Remember, your terms are the things that you're adding and subtracting together, okay? So this is a term, one term, two terms, three terms, okay? Your leading term is going to be your term with the highest power. So my leading term, not leading coefficient, notice the word is term. Your leading term is going to be the whole thing, okay? So in this case, my leading term would be C, 4x to the fifth. Does that make sense? Your leading coefficient would just be 4, but the leading term would be the whole thing. All right. Do y'all remember Bob and his 4 dance moves? Bob only has 4 dance moves. He likes to wave his hands in the air like he doesn't care. He likes to bring it on down, bring it on down. He likes to stand alive. He likes to pump it up, right? Okay. So those are Bob's 4 dance moves, and we have to decide what are Bob's dance moves for this polynomial function. So he has negative x to the third plus 2x squared minus x plus 4. So the first thing we look at is our leading coefficient. Is our leading coefficient positive or negative? Negative. So my right side is going down. Next, we look at our degree. Is our degree even or odd? Odd. So that means that my left side is doing the opposite, right? So Bob is pumping it up. This is what his end behavior is doing. Okay. So based on this, what is his as x approaches positive infinity, which means I'm going to the right, what am I doing? What are my y values doing? They're approaching what? They're going down, so they're approaching negative infinity. So again, like we said, because it's a negative leading coefficient, the right side is going down. Because it's an odd degree, the left side is doing the opposite and going up, right? Next, a polynomial of degree 6 can have at most how many turning points? So this is a word that we probably didn't hit a lot. Your turning points are your max and min. So when you transition from increasing to decreasing, that is a turning point. Your turning points, I call them TPs, are going to always equal your degree minus 1. That's going to be your max turning point. Okay, so that's my max turning point for this one. My degree is 6. So what's my max turning point? 5. That's how easy turning points are. Okay, so that means I can have up to 5. Does it mean I'm going to have 5? No, I can have up to 5. It's just like if you work a job and they'll tell you, you can work up to 20 hours a week. Do they always give you those 20 hours when they first hire you? No, it's a scam. They don't, especially when you're under 18. Okay, they usually fill in the gaps. Be warned. Kaylee's like, yes, that's what happens. Okay. All right, next. So in behavior, it says which polynomial will have an end behavior where both ends point upward. Okay, so both tells us that our degree has to be what? degree? Even. So we know that our degree has to be even, and upward tells us that our leading coefficient has to be positive. There we go. So what's my answer choice? Which answer is correct? There you go. D. All right, so that was our quick review of what we learned, correct? Did any of that feel super too bad new besides turning point? And turning points is easy. It's always a degree minus 1, and we're all experts at subtracting, right? All right. All right, so continuing on what we already know, we're going to introduce some more new stuff. So we have comparing polynomials by the degree and the shape of the graphs. So we're also going to interpret our zeros. So your zeros are where you cross the x-axis, correct? And our relative maximum and minimums, your maximums, your mountains. We talked about maximums. We talked about minimums, our valleys, our mountains and our valleys, right? Our peaks and valleys, okay? And then we're going to talk about multiplicity and how repeated roots affect graphing behavior. So multiplicity is when you have, this is like the new piece. Multiplicity is when you have a polynomial written in factored form. So let's say I have x minus r. The multiplicity is the power on the outside of the factor. Does that make sense? So the multiplicity is the power on the outside, okay? Based on your multiplicity, different things are going to happen to your function, but that's what the multiplicity represents, okay? All right, so number 1, it says which of the polynomial has the highest degree and would have the most extreme in behavior, okay? So, easy question, highest degree. What's my highest degree? 5, exactly. Okay, and extreme in behavior is really not extreme. They just have opposite in behaviors, right? One's going forever to the negative infinity, and one's going forever to positive infinity. All right, new piece here is your multiplicity. Multiplicity is telling you how a function behaves. So there are three types of multiplicity that we're going to focus on. There's odd multiplicity and there's even multiplicity, okay? Odd multiplicity, odd is going to cross the x-axis. That's all we need to know for Algebra 2. Even multiplicity is going to touch the x-axis. Okay, so odd crosses, even touches. Okay, when we say cross, it can look like a couple things. So for example, this is an example of just crossing. Like I just go through the points. Do we see that? Another example of just crossing, I like to call this one, it probably sounds a little weird, I call it a drive-by because the function is moving kind of slow. It's going to creep up to it and it's going to zoom past it. So it has like a little flattening and then it keeps going, okay? That's another. Typically, this is when your multiplicity equals 1, and this is when your multiplicity equals 3 or any other greater odd number, okay? Your even, I like to say these kisses the line. Your even multiplicity, how many of y'all have seen a quadratic that sits on the x-axis? Yes, we've seen those. Those have even multiplicity, okay? They're going to just give a little peck, a little kiss. There you go. Boom. It kisses the x-axis, okay? All right, so now looking at what we have here, we have zeros at x equals -2, and it has a multiplicity of 2. Because it -2 multiplicity of 2, which behavior is it going to do?
Barely touch it.
It's going to touch it. So it's going to be the one the graph touches the x-axis and then it keeps going, bounces off, comes down, and go. Does that make sense? All right, so all you're doing is looking for what type of multiplicity. An odd is going to cross, an even is going to touch, and in pre-cal, you'll dive a little deeper. But for Algebra 2, those are the main things we need to know. Peace. All right. So next, we have a polynomial with a degree 4, a positive leading coefficient. Which statement about its graph is always going to be true? Okay. Always means that there's no exceptions. And the thing here is that when you have it can have up to 4 x-intercepts because the degree is 4. Your degree can equal sometimes your x-intercepts. It's not always, it's a sometimes. So it can't be A. Next, as x approaches infinity, f of x is approaching negative infinity. It said my leading coefficient is positive. So am I going to ever be heading to negative infinity? Nope. As x approaches infinity, f of x approaches positive infinity. Is that true? That's going to be always true, right? If I'm a even and happy, I'm going to go to infinity. And then the last thing is it must have 3 turning points. Must is the problem. It can have at most 3 turning points. Okay. And I'm going to show you an example of why these may not always be true. So we're going to go to the handy dandy DESI mode. If I click the right thing. All right, so here in Desmos, I'm going to graph the standard quadratic cubic quartic function. So this is a 4th degree polynomial. Okay, this is one where it has a multiplicity of 4 because there's nothing else there, right? It's just factored as x to the 4. It's an even multiplicity, so notice that it's just doing what at 0. It's just giving a little peck and doing a lot of weird bouncing in between. It doesn't touch any other part of the x-axis. It's very, very, very close. Okay. So that's what that would look like. Now, if I wanted it to have its full on 4 x-intercepts that it could, then that means I have 4 factors that are taking place here. And it doesn't matter. I'm just putting in a model for you. And then we're going to do x plus 3. So notice now, this would be a quartic with 4 x-intercepts. Do we see that? So that's an example of 4 x-intercept. However, it doesn't always have 4. As we just saw, the first one only had 1, and it also can only have 3. Why that happens is because I can have 2, I'm sorry. Okay. So notice in this example, I have 1, 2. It only crosses at 2 locations. Well, that's not it. Let's try that again. I need a power on there. There we go. It only crosses at 2 locations. And for each one of them, they are kissing because it has a multiplicity of 2. Okay. So that's why we can't say that it's going to always have 4 x-intercepts. It can have up to 4, but is it going to be a guarantee? No. And that also is going to affect its turning points. Cool? All right. Next, it says how many relative maximum and minimum points can a 3rd degree polynomial have at most? When you're describing maxes and minimums, you're describing your types of turning points. If you have a 3rd degree polynomial, that means that at one point from left to right, you can increase, decrease, and then increase again. Or you can decrease, increase, and then decrease. These are your only options for a 3rd degree polynomial. So out of these options, which statement would be true? You would only have 1 maximum and 1 minimum. All right. Next, going back to multiplicity, we have x equals 2 and it has a multiplicity of 3. Is that an even or odd multiplicity? Is the thing you should automatically ask yourself. And we know that is odd. So it's an odd multiplicity. And what do we say odd multiplicities do? It crosses the x-axis. Okay. When we get into pre-cal, this would be the answer we would select. Uh-oh. This would be our pre-cal answer, the points of inflection. And that's because your curvature of your graph is changing. But are we in pre-cal yet? No. So all we got to focus on is it crosses the x-axis, okay? But when we get to pre-cal, we're like, ooh, I've heard something about a point of inflection at one point. Okay, you won't remember. It's eight.
Yeah.
It's 8 days left in school. If
Yeah.
that. Is it? Yeah. 8,
Somewhere around there.
9? Yeah. Y'all don't have that much time in school, so I highly doubt you remember this conversation. Friday? No. We take our EOY on Thursday, but Friday is just kind of like a catch-all day. We take our district EOY. Today's only Tuesday. I'm sorry. Sorry, Brooks. Sorry. All right. Next. Now we're gonna talk about building polynomials with complex numbers. Complex numbers, do you guys remember that with radical functions, not radical, yeah, with radicals, square roots, you're not allowed to have a negative underneath the square root. Does that ring a bell? Okay. So what happens is when there is, it creates what's called a complex number. Okay. So when you have the square root of a negative number, that equals what we call I. Okay. I don't know why. I've always, since I learned this in 8th grade, I've always wrote my I like this, and I don't write I like this at any other time. But for whatever reason, I feel like in math it has to be different. It's just an I. Don't ask me. Don't know why. Just roll with it. Um, it's just a plain I, and I don't know why I have to put the curve on it. I never do. But it's an I. So when you have the square root of -1, that equals I. So for example, if I have the square root of -4, it's going to be the negative tells me that it's a I, and then I can take the square root of 4. What's the square root of 4? 2, right? So it's positive or negative 2, but I'm going to have to include the I in order to take it out. That's all a complex does, is it allows you to work with a negative underneath the square root. Does that make sense? Okay. I know we're doing this fast and furious, so y'all are doing great. When you have I squared, that equals -1. So I squared equals -1. That's because all you're doing is squaring the radical, and when you square a radical, it sets whatever underneath the screen. Okay. So two things that we need for this is square root of -1 is I, and I squared equals -1. I remember you saying, I scream, you scream, we all scream for I squared. And I don't know why she said it, but yeah. Okay. So here we go. What is the polynomial equation if the zeros are 2 plus I and 2 minus I? When you have 2 plus I and 2 minus I, that means you had factors before. Your factors before are going to always be, your factors are going to be the opposite of what you have. So when you have, so for example, my first factor is x minus 2 plus I. That's going to be one factor. My other factor is going to be x minus 2 minus I. Okay. And then all you're going to do is clean these up and multiply. Okay. If you're not strong at multiplying with traditional distribution, then you can just use the box method. It helps it, especially with I's, it helps it stays a little cleaner, a little more organized. So I'm going to set up a 3x3 box for you. To model it. We're going to pretend that those are straight lines and equally spaced boxes. Okay. So my first, I'm going to use this as my first, which is going to be x minus 2 minus I. Then my side is going to be x minus 2 plus I. All right. And all you're doing is multiplying. So filling the x times x is x squared, Ms. Jones. I know we're going to make it. X times -2 is -2x. X times -I is -ix. X times -2 is -2x. Negative times a negative is a positive. -2 times -I is going to give us positive 2i. I times x gives us positive ix. -2 times I gives us -2i. And positive I times -I is -I squared. Okay. Do you see why I kind of encourage the box? Because it helps it stay a little neater, a little more organized. Do you have to use the box? No. Once you're in the box, there's two steps that are going to take place. You're going to eliminate, and then you're going to combine like terms. Eliminate, combine like terms. Eliminate, combine like terms. So what can I eliminate in the box? Huh? I can negative 2x. I can't eliminate negative 2x because they are, but I can eliminate ix and negative ix. Remember, you only can eliminate when they are opposites of each other, right? And I can eliminate positive 2i and negative 2i. So what I'm left with, x squared has no friend. I have negative 2x and negative 2x, and that makes negative 4x. I have 4, and I'm left with negative I squared. What does I squared represent? Negative 1. So when it's all said and done, my final answer is going to be x squared minus 4x. And a negative times a negative makes a positive. So 4 plus 1 is 5. So my answer would be A. And that's how you multiply complex numbers. How do we feel? Okay. Complex numbers are going to always come in a pair. So if they only told me 2 plus I know that the other one had to be 2 minus I. Does that make sense? Because they come in a pair. You cannot have one without the other. Okay. Let me tell you about my best friend. Okay. They come together. All right. Next, we're going to talk about writing a polynomial function based on its zeros. When you are writing a polynomial based on its zeros, you have to remember that x's are liars, okay? Your factors and your x's are going to always be the opposite. So if you're, in this case, our zeros are 2 and 3, okay? Meaning that we're at 2 comma 0 and we're at 3 comma 0. So their factors are going to be the opposite. So if I'm at x 2 comma 0, my factor is x minus 2. If I'm at 3 comma 0, my factor is x minus 3. That's how we go from zeros to factors. Does that seem doable? So we go from zeros to factors, and obviously our answer would be D. Okay. Do you think it changes? Is that a negative? We're going to pretend that that's not there, okay? You see nothing. You saw nothing. We're going to treat it as a positive 2 and call it a day. All right. This time we'll treat this one as a negative. Do you think it's going to change just because I have fractions? No, fractions are our friends. Okay. We treat all of our friends equally with love. All right. So this is supposed to be a negative 1/3. So we're going to make it a negative 1/3. So our zeros are 1/2 comma 0 and negative 1/3 comma 0. And I need to write them as a factor. So what is the factor for this one? X's are liars. So when I write it as a factor, it becomes minus 1/2. Because if I plug in 1/2, that's how I get 0. Does that make sense? X is a liar. So we have x plus 1/3. Okay. And then at that point, how do you find the polynomial? What would you do? You would either quote unquote FOIL or multiple distribution, right? If you don't like doing FOIL or multiple distribution, you do always have the handy dandy box that you can fall on. Does that make sense? How many people prefer the box over multiple distribution? Nobody? Nobody? No? Okay, cool, cool, cool. It's okay. So let's go over FOIL then. All right, so FOIL. First times first gives us x squared, right? Our outside gives us 1/3 x. Our inside gives us negative 1/2 x. And our last gives us negative 1/6. Because I know my constant is negative 1/6, what can I eliminate already? We can eliminate C and D because their constant is positive 1/6. Okay? And now, in order to combine fractions, what do they have to have? Fractions have to have what? Common denominator. So if I have 1/3 and negative 1/6, how can I combine them? What would be their common denominator? The LCD of 3 and 2 is what? 6. There we go. So 1/3 becomes 2/6, and 1/2 becomes 3/6. Agreed? And what does that equal? Negative 1/6. So our x's combined to make negative 1/6. Which one of our x's is negative 1/6? A. So the answer would be A. Yeah, you've missed a lot there, buddy. All right. So again, we're going to keep practicing multiplying. So here it says, which polynomial has zeros at 2i? Remember, if I'm at 2i, I'm also at negative 2i. Okay. So we're going to write our factors. So if I'm at positive 2i, my factor is going to be negative 2i, right? If I'm at negative 2i, my factor is going to be positive 2i. And again, at this point, you have the choice to either FOIL or box method, whichever makes your heart happy. So we have x times x is x squared. X times 2i is positive 2ix. 2i times x is negative 2ix. And negative 2i times positive 2i is negative 4i squared. What happens in the middle? They cancel out, and we're left with x squared minus 4. And what does I squared equal? Negative 1. So we're left with x squared plus 4. So which is our answer? There we go. The answer is A. All right. So number 5 is a unique thing. It's asking you for x-intercepts and y-intercepts and which equations would satisfy the two, right? So it's asking for x-intercepts at negative 1 and 2, and it's asking for y-intercepts, a y-intercept at 0, 6. Be honest with you. For your y-intercept, the main thing that you're just looking for is your constant, okay? Your y-intercept is going to always be your constant. Okay, your constant is your number without a variable, correct? So without graphing, I can identify which one that is. Does that make sense? So my constant here is negative 2. Is that 6? No, so it's not A. My constant here is 6. Oh my gosh, my constant is 6. Surprise. It's crazy. Okay, so my constant is at 6. And I'm like, all right, that seems to work itself out. I'm a genius. Make sense? Doable? And then, so let's just graph it to see. So we're going to graph negative x squared plus x plus 6. Negative x squared, was it plus x? Plus 6. All right. This does not satisfy. Negative 2 It doesn't satisfy y'all. I messed up something. I'm missing something in this. This needs to be moved. There should be a number here, and I don't. Just gonna ignore this. This is call your teacher being transparent with you. I just want to make sure you know what the x-intercept was. That's it. No, I'm playing. I think I forgot a number. It's hard making multiple choice questions. I'll fix it later. But the main thing is, do we know what x-intercepts are? Do we know what y-intercepts are? Okay. Graphically, we do, and if we don't, it's the constant. This does have a y-intercept of 6. The rest was not true. Let me look at this again. Maybe I wrote the numbers wrong myself. Yeah. You know what? We'll just make it true. What are you talking about? There we go. Yeah, the answer's B. Fixed it. Joke was on you. All right. I want to thank y'all because this is like this would have been like a whole day lesson, by the way. We're cramming real hard right now. You know what time it is. What time do we get out of here? 45? Okay. So we have 10 minutes. Whew, okay. Next, we're going to be talking about rational. A rational function means that you have a variable in the denominator. Okay. So rational, it can be anything in the numerator, but the main thing is that you have a variable in the denominator. Okay. So this is your numerator. But you have a polynomial in the denominator. Okay. By variable, we mean polynomial. Okay. You're going to have a polynomial. All right. So with that, how many of your teachers, do y'all remember your teachers saying it is okay for 0 to be in the numerator, but it is a no-go for 0 to be in the denominator? Has anyone ever heard that? It helps you remember that you can divide 0 by something, but something not by 0. Okay, well, now you have. So it is okay for 0 to be in the numerator, but it is a no-go for 0 to be in the denominator. So when we have rational functions or equations, we have to pay attention to the fact that our denominator cannot equal 0. Does that make sense? Okay. All right. So here we have, which of the following is a solution to the polynomial? This is just solutions. This is graphing. If you were to graph x to the third minus 4x squared plus 3x equals 0. Y'all remember how I said there's going to get to points where things just double copy? This is the point. I was like, wait, I did it. This is where the double copy happened. I don't know why. I don't know how. And I didn't realize it until I printed all these papers and, I was against killing trees. So this is the page that has duplicates of all the functions, and I don't know why. It's the weirdest thing. But anyways, so what you're doing here is you're graphing. You either can graph or you can factor. It's really, quite frankly, up to you. I'm going to encourage you for the test, for your checkpoint, for your final, for your EOY. If there is a function, you graph it. Okay? If there is a function, you do what? You graph it. Okay? So we're going to graph x to the third minus 4x squared plus 3x. So we have x to the third minus 4x squared plus 3x. Did I remember that correctly? Yeah. All right. It asks you for your solutions. Your solutions are your x-intercepts. So where are my x-intercepts? I have one at 0, I have one at 1, I have one at 3. They're your solutions. Okay. In the beginning, we were really focused on solving by factoring. Now we're at the point where, oh, here's this tool to help you. Be great. Okay. So when it says solve or equal to 0, the key thing is that it has to be equal to 0. That's what that zero product property is telling us. When it's equal to 0, all we have to do is graph and look at our x-intercepts. Does that sound doable? Okay. All right. Next, it says when solving rational equations, which value is an extraneous solution? Your extraneous solution is referring to your denominator. So when we see this, you're taking your denominator and setting it equal to 0 because extraneous means extra. That means it's not a real solution. And what's not okay in the denominator? 0. 0 is okay in the numerator, but it is a no-go in the denominator. Okay? So you're taking your denominator and setting it equal to 0. Our denominator is x minus 1 equal to 0. What is our extraneous solution? I promise you, you won't get it wrong. X equals 1. Remember I told you this is where the weird duplicating happened? So the answer is A. That's our extraneous solution because that would make our denominator equal to 0. If you didn't have a denominator or your denominator was eliminated, then there would be no extraneous solutions for this one. All right. See. We're gonna. Why did it do this, guys? To annoy me? To make me cry? Duplicates are gone. Which polynomial equation can be factored by x plus 2 times x minus 3 times x plus 1? So these are all powers. It's supposed to be x to the third minus 4. I swear I used the little math equation thing. I don't know. Anyways, this is just multiplication. Do y'all remember our unit on multiplying polynomials? Okay. You have a couple options here for multiplication. Box method or just traditional multiplying. However, you only can multiply two numbers at a time. So that's the same for factors. You only can multiply two factors at a time. So when we multiply in our factors, I'm going to start off with x plus 2 and x minus 3. So multiplying, we have x plus 2 times x minus 3. X times x is x squared. X times negative 3 is negative 3x. 2 times x is positive 2x. And 2 times negative 3 is negative 6. I'm deliberately going fast because at this point, we all should be able to multiply. Correct? So we combine like terms and we get x squared minus x minus 6. Now we're going to multiply by our last factor, which is x plus 1. And you're just going to multiple distribution again. X squared times x is x to the third. X squared times 1 is 1x squared. Negative x times x is going to give us negative x squared. Negative x times 1 gives us negative x. Negative 6 times x gives us negative 6x. And negative 6 times 1 gives us negative 6. So putting it all together, and what do we got? We have x to the third. What happens to your x squareds? They cancel out. We have a negative x and a negative 6, which makes negative 7x. And we have minus 6. So our simplified answer is, we're going to pretend that these are powers. So the answer would be C. All right. Number 4. Why is x equals 2 not a solution? Last one. I let you go. Anybody? Everybody? There we go. It makes the zero denominator in the first fraction. And is that okay? No, it is a no-go for your 0 in the denominator. All right, and this one we're gonna just kind of ignore. But just FYI, you can use quadratic formula. In pre-cal, we'll learn to use U substitution, but for us, it's just quadratic formula. We're not going to do much of that. How do I know it's quadratic formula? It's because the degree of the first term and the degree of the second term are half one another. So it'll just end up working itself out. All right. So what's going to happen is I will unlock the test. It'll be unlocked until when?